Hello from Group 5, the Backseat Boys. Our project is an application called Parking Buddy, and we are super excited to present our work to you today. But first, here's the team behind our app. Hi, my name is Nick Parisi, and I am the product owner for Parking Buddy. My primary job was to head up the React team and work on the user login page.
I'm Seamus McFarland. I'm the Scrub Master, and I worked on the Node server.
Hi, my name is Alex McAuliffe. I was on the coder team, and I worked on the AI image processing code as well as the React app code.
Hello, my name is Sean O'Brien. I worked as a programmer on the React core team and the router team.
Hi, I'm Max Johnson. I'm a designer and helped assist with the coding of the user interface.
My name is Nathan Liddell. I was a programmer responsible for the Node server implementation.
Hello, my name is Chandler Hummingbird. My main job was the polishing of AI code, and I'm also the editor for this video.
Ever been late to class and need to find parking fast? Tired of driving in circles whenever you go to a football game? Parking Buddy is here to help. Our app allows its users to be able to find good parking locations quickly and conveniently. It works by using AI image processing to determine which spaces are open and which ones are occupied. All you have to do is select a lot, and then it will provide you with an open location. Parking Buddy can be used in a variety of situations. Students can use it to find parking locations at their school, while event goers can find spaces among crowded lots. It can help when you're having trouble finding a parking spot or when you just want to save a bit of time.
Current parking spot availability services like smart parking take the form of sensors placed above or below a parking spot to detect vehicles. However, this can be expensive. We propose a cheap and convenient solution. Parking Buddy removes the need for so many sensors and replaces them with a single camera. Many lots already contain some sort of pre-existing camera for security, which can be easily adapted to work alongside Parking Buddy. This means that many locations already have what they need to work with our app. Another strategy to keep track of available parking spots was used by a South Korean petrol company called S-Oil. To save customers gas, S-Oil placed bright yellow HERE balloons to indicate free parking spots. Drivers would lower and tie down the balloon they parked at. While this system is simple and technology-free, it is less convenient and reliant on the actions of customers.
Parking Buddy puts the parking information you are looking for at the tips of your fingertips. Through accessing Parking Buddy on your phone, you can compare lots and park quickly and conveniently without having to be anywhere near the lots you are observing.
The hardware required for the implementation of Parking Buddy consisted of an outdoor security camera, drone, and our smartphones. The security camera and drone were used in order for the AI to get a real-time picture of what each parking lot looks like.
On the software side of things, we used OpenCV to label our training images, TensorFlow to train our algorithm, RoboFlow to source our publicly labeled parking lot images, Google Colab to run training and testing of the AI model, Node.js for the intermediary server between the front and back end, JustinMind used to create the UI prototype, React for our mobile app development, GitHub to source all of our code, Discord to communicate between group members, and ClickUp to keep track of our project and continue to make sure that we were on pace.
Now we follow the story of little Jimmy, a commuter student at TU who hit some bad traffic on the drive. He needs to find a parking spot, and fast. Pulling up the Parking Buddy app, little Jimmy quickly signs into his account, making sure to tick the Remember Me box so he won't have to enter his login details in the future. He is immediately presented with a list of nearby parking lots, with the closest lots at the top of the list. He sees that the nearby commuter lot is already full, so he chooses the nearby Student Union parking lot instead, which has 8 open spots.
Oh, perfect. It looks like this lot has some open spaces. I'm just gonna park here.
Just as little Jimmy is about to pull in the parking lot, he sees the perfect parking spot open up just for him. In the grid view in the app, he sees the A12 parking space change from closed to open and makes his way over to that spot. As little Jimmy is about to pull into his parking spot, he sees the parking spot A12 that he just pulled in change from open to closed in real time inside of the Parking Buddy app. He wonders what kind of geniuses were able to make an app this simple yet this effective.
Perfect. Thanks to Parking Buddy, I'm gonna make it to my exam on time.
Little Jimmy has just become Parking Buddy's first satisfied user. Now let's rewind and look at a behind-the-scenes view of our app processing parking lot video footage in real time. On the top left, we see video footage of the Student Union parking lot, which has green and red rectangles placed over each parking spot. These rectangles come from the output of our AI image processing algorithm. Red squares are placed over occupied parking spots, and green squares over free spots. On the bottom left is the output of our Node.js server, which updates the status of the parking lot every few seconds and sends this information to the Parking Buddy app. On the right is the parking lot grid view seen in our application, which is constantly requesting updated lot information from our Node.js server. As we see a car start to pull out of its parking spot, we see the rectangle change from red to green because the AI has indicated that that spot is now open. Additionally, we see that the console at the bottom left is now reporting 11 open spots rather than 10. And in a few seconds, the A12 parking spot is updated on the app parking lot grid view. As we see little Jimmy begin to pull into the parking spot, we see the green rectangle change to red to indicate that the spot is now occupied. And we also see the A12 parking spot shift from blue to red in the parking lot grid view. Additionally, the console at the bottom left is now reporting 10 open parking spots instead of 11.
Moving forward with our project into the second semester, we have come up with a few ideas for additions to our product that we believe will help improve the usability and increase the functionality of our application. We came up with most of our ideas for improvement through struggles and roadblocks that we encountered when designing and implementing our own code. The first of these ideas is to facilitate more account personalization. Through this feature, we plan on giving users the ability to designate their favorite or most frequented lots, so that they may be able to receive information that is more catered specifically to their most common uses. For example, this would enable Parking Buddy to send the user a notification if the lot that they always go to is full or doesn't have any spaces available. Our second area for expansion within Parking Buddy is with parking lot analytics. The idea behind this is for our app to record and save data on which parking lots are most frequently used and the timeframes for which this is the case. This would allow for property owners to make decisions based off of our data. This could be used to investigate ideas such as whether or not a new lot should be built or to help influence the rates for parking lot passes and fines. Lastly, we would like to thank you for your time and consideration of our project. If you have any suggestions for areas for us to improve our app or ideas that you think could help us make us better, please scan the QR code and share them with us. We love any and all feedback. Thank you.